Hello Chemistry 119 students, and welcome to our Acids and Bases lab. The goal of today's lab is to learn to use pH meters to measure the differences between strong and weak acids and bases. Today's lab will be a two-part lab. In the first part, we will be observing the pH of some common solutions, and in the second, we will be measuring the pH of some strong and weak acids at different concentrations. Let's get started on part 1. Before we get started measuring the pH of any solution, we must first prepare our pH meters. To do this, we must calibrate them in two solutions with a known pH. Today, we will be using two buffers of pH 7 and 4. As a reminder, a buffer is a solution that, due to its chemical makeup, resists change in pH, even with the addition of bases or acids. What makes an aqueous solution acidic or basic is acids or bases breaking down into OH- or H+. A buffer works by containing a weak acid to mix with OH- and its conjugate base to mix with H+, thus limiting the pH change of the solution. Alright, and we're going to go over here and we're going to touch 4 on the screen, and we're going to wait keep. Alright, now take it out of the 4. We're going to wash it off with our little spritzer. Okay. Awesome. Now we're going to put that into the 7. Leave it in there for a little bit. We're going to go over here and click 7 on the screen. And we're going to apply. Alright, and now as we realize, we're in the 7. It's reading about 6.99. Awesome, that's exactly what 7. There we go. Now that our pH meters are calibrated, we can start measuring the pHs of some common solutions. We have 6 common solutions we are going to be measuring for this part, those being 0.2 molar acetic acid, 0.2 molar HCl, 0.2 molar NaOH, and 0.2 molar NH4OH, as well as apple juice and orange juice. Quick reminder that in between measurements, you always have to wash your meter with deionized water to keep your readings accurate. Our last one, which is NH4OH, and this should be a weaker base. Throw it in there. Alright, you can see a slightly lower number than what we saw on the NaOH. A little less than a 12. One, 2, 3. All right. Okay. Yeah, take it out, and then we'll wash it out for the last time. And then we'll place it in our water. Yeah, throw it in there. Awesome. Our full results for this part are listed here. For part 2, we had to compare the pHs of a strong and weak acid at different concentrations. We created and measured the pH of a 0.2 molar, 0.15 molar, 0.1 molar, and 0.05 molar solution of HCl and acetic acid. 0.15. Right there. We're seeing the concentration the pH a little different there. Looks around, it's like a 2.6. Maybe a little lower than that, 2.55. Let's put that down, 2.55. Here are the full results of this part. Notice that the strong acid has much lower pH values across the board than the weak acids. This is because strong acids fully dissolve in aqueous solutions and thus produce more H+ than weak acids, which only dissolve partially in aqueous solutions. Finally, now that we have completed all of our measurements, we can finish the lab by properly storing our pH meter.